Okay, chapter 9 this course is on solids and fluids. So we're really stepping away now from what we've been doing with Newton's laws and motion and kinematics, all that jazz, uh, and getting into some areas that are quite a bit different. Um, First, we'll just talk about the states of matter. You've probably all seen this, and I'm sure that you had this in grade school even, but it's worth recalling here. So we have three states of matter, of course. There are solids, liquids, and gases. Solids have a very rigid or ordered structure. The atoms don't move very much with respect to one another, so a very ordered structure, ordered and rigid structure, atomic structure, that is. Liquids, on the other hand, have a less ordered, a more fluid structure. So if we were to look at the atoms of a solid, they wouldn't move with respect to one another. But liquids, on the other hand, the atoms sort of move around with respect to one another. And then for gases, even more so, the atoms are very rarefied. They're very far apart from one another. There's a fun little video about the states of matter. It's really for your own interest, but it's from They Might Be Giants. You can watch that here if you like. Now, there is a fourth type of matter, a type, let's put that in parentheses, uh, a plasma is a fourth type of matter, and it is an ionized gas with approximately equal numbers of positive and negative charges. So completely ionized gas where all the electrons have been stripped away from the nuclei. These can occur in a couple different ways. Plasmas are usually on very hot objects, very so hot that it provides enough energy to strip those electrons away from the atoms. For example, on the surfaces of stars. So I have another little They Might Be Giants. You don't have to watch it if you wish, but here it's very interesting about plasmas. Um, but gases can be ionized in other ways as well. And if you've ever seen one of those little balls where you have like a glass ball, and then inside the glass ball, you have the little arcs that are coming out, that is a plasma. And that plasma is not hot, obviously, because you can touch it, but it is ionized by an electrical energy. If you've seen the movie The Prestige, then you've seen a plasma in this way, the scene where Tesla walks through this device. You can watch it on YouTube. Really, it's just for your own interest there. Now, there's another type of matter. This isn't a phase of matter or a state of matter, but it's called dark matter. And dark matter is called dark because it's matter that doesn't emit or reflect light. Doesn't emit or reflect light. So it is, dark. Um, it's not necessarily a state of matter, but it's something that we don't really know what it is. So it could be some other type of material that we just don't know. Now, the presence of dark matter was inferred through the observations of galaxies and their rotation curves. The rotation of galaxies by Fritz Zwicky in the 30s, and then later it was verified, or actually really driven home by Vera Rubin in the 1970s. What they did is they looked at galaxies, and you look at a galaxy, looks something like this. It's made up of stars, and you can infer the amount of mass that's in a galaxy by looking at the stars. So you look at a galaxy that's made up of stars, and you count up the number of stars, or you can tell how bright the galaxy is, and then from that you can infer how many stars are in the galaxy, and you know to pretty good estimate what the mass of each star is. So you can get some estimate of the mass of the galaxy, and that's just from the starlight, right? But then they also looked at how these stars were rotating in the galaxy, and from that you can get another estimate of the galaxy, which is from the rotational velocities of the stars within the galaxy. Right. So what they found was that stars were rotating much faster than they should have been, like around the center of the galaxy. And so they inferred then that the galaxy was mostly this material which they call dark matter. It's thought to be that maybe 90% or more of the universe is made up of this so-called dark matter, but it's not really known what it is. Over the years, there have been a lot of proposals, and there's a lot of work now to determine what is dark matter, but no concrete answer as of yet. People have proposed that these are rocks out in space, but there aren't really enough rocks in interstellar space to make up the vast quantity of dark matter that there is. People have said maybe molecular hydrogen, which doesn't emit very much light just because of its structure. But not enough molecular hydrogen in the universe to account for the amount of dark matter that there is evidence for. I have a little 1-minute clip. You just need to know what dark matter is. Oh wait, no. If you knew what dark matter was, you would win the Nobel Prize. But you need to know how it was discovered by comparing these masses of galaxies based on the rotation curves and the visible light from the galaxies. And the rotation curves gave a much higher value for the mass of the galaxies, and that it makes up, most of the universe. Here's a little short video. This is from Minute Physics. It's really just 1 minute.